We are going to work with scientific notation. What is scientific notation? That's a method of representation of enormously large or enormously small numbers in the format that is much more readable. When we are talking about enormously large numbers, we are talking about it can be 24, 33 digits, okay? So one can even make a mistake by reading such numbers, but it will be very easy to read in the format of scientific notations. So what's the format of scientific notation? It is an n times 10 to power k, for example. So where n supposed to be between 0 and 10, okay? N greater equals 0, it can be 0 point something, but less than 10. There is no equal sign, pay attention, because cannot be 10. It has to be one digit, whole number, okay? Okay. Didn't work. So, one more time. There we go. All right. Let's solve it. Let's assume I have 8, 7, 3, 2, 5, 2, 7, 1, and 0, 0, 0. Okay? So, how I'm going to represent in the format of scientific notation. All right. Our number n that can be between 0 and 10, which means it cannot be 873, it cannot be 87, it can be 8. So it's going to be equal 8 point and the whole 9-yard numbers, 3, 2, 7, 1. These zeros makes no sense to write down because in the format of decimal notation, the last zeros, it doesn't do any difference. Times, let's see how many times we made it smaller, this number. Let me see. 1, 2, I'm going from here. 1, 2, 3, 4, 5, 6, 7, 8. Point is here. So 8 times. That's therefore, because I cannot disbalance the number, I cannot change the number. So if I put 8.73271 times 10 to power 8, okay? So once I move the 8 times, you will get the original number. The trick here is, so when I have, let's say, number 2, when I have number 2, so I can put here point and 0, right? So it doesn't matter. When you multiply by 10, you can move by one digit to the right, and it will be your multiplication by 10. If I want to multiply by 100, let's say 2, which is 2.0, right? Same 2.0. So from this point, I have to go 2 zeros, that means 2 digits, 1 and 2. So it's going to be 200. Okay? If I have 2 and I want to multiply by 1,000, so 2 point, then 1, 2, 3. See, 1, 2, 3. And I will get 2,000. Same way division. I have 2. Want to divide by 10. This is my point, right? 2 point. So when I'm doing division, I'm moving to the left instead of to the right. So when you move to the right, that means you are multiplying. by as many tens as the zeros you have there. But let's say divided by 10, you move by one position here, and it's gonna be 0.2. I would rather put 0.2. Divide by 100. Okay, this is 2. It's right here. By 100, 1, and then 2. This is where you're gonna be your point. So 0 and 0. Get 0.02. Dividing by dividing by 1,000. Let me fix this. This looks like addition. So dividing by 1,000, this my 2 point is here. So by 1,000, it's gonna be 1, 2, 3. So 0, 0, 2. Here is 0. 0.002. Okay? So therefore, now back to our number. 873,271,000. So we have to have the number that is less than 10, and it's going to be only 8. So 8 point, and from here 73271. So to get the original number, I have to multiply by 10 to power 1, 2, 3, 4, 5, 6, 7, 8. That's why we put 8. Okay, let me clean this so not to make a mess. Or we'll see. Okay, maybe I can write down the weight so it won't bother me. So let's do one more. 4, 3, 5, 6, 7, 9, and 7, 0, 1, 0, 0. Okay. Actually, let me add one more 0, otherwise I have to change this commas. Okay, how much it's gonna be? Let's see. I'm going to write down. Let me start from here so I will have enough space. I can't take even 43 because it's greater than 10. So it's going to be 4.3, 5, 6, 7, 9, 7, 0, 1. I'm writing down the whole 9 yards. Okay? So times 10 to power, how much? So I put decimal here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to power 11. Okay, let me clean this so original one won't be. All right. Okay. Next. So let's see. 0 point, now working with enormously small numbers. 0, 0, 0, 6, 1. So in that case, it's gonna be, I have to go 1, 2, 3, 4 positions, 6.1, right? So I will have 6.1. Since 6.1 is much greater than 0.00061, then I have to multiply by, meaning divide by how many times? 1, 2, 3, 4, right? So how I'm going to divide by the 10,000? So divide, instead of, we don't put in the format of division, we always want to put in format of multiplication. But to mean division, I'm going to put 10 to power negative 4. Look how nice it is. Because it's the same thing if I would write down 6.1 divided by 10 to power 4, which is 6 to power 6.1 divided by 1, 2, 3, 4, and I would get exactly same number from 0.61. I would go to the right, to the left 4 digits, and I would get the same number. This is why when we multiply by number in negative degree, that means realistically we are dividing. Okay, one more example like that. 0.0346781. Okay, let me represent in the scientific notation. So I cannot put 781, I can put only 8. No, I can put only 3.41. So, well, it's not exactly the best one. 3.46781. I'll bring another example. Times. So if I have 3, so I moved by how much I have to move back? By 100, right? 1 and 2 zeros. It's going to be 10 to power negative 2. One more. Let's do one more. 0.0000000 and then 375. Okay, so I have to write down 3.75 because I cannot write down 37.5. It's going to be greater than 10. 3.75, which is going to be here. So now let's see how many digits we are going to go back. 1, 2, 3, 4, 5, 6, 7, 8. So which means it is going to be 10 to power negative 8 because we are dividing practically. Oops. 3.75 times 10 to power negative 8. Okay. Let me see. Let me go vice versa now. Let's do vice versa. We have number, for example, 4.38 and multiply by 10 to power 7. So we take from 4, 1 and 2, we get here 438. So I moved 2 positions, right? Another 5 I need to add. 1, 2, 3, 4, 5. So look what we had. We had it here, right? 1, 2, 3, 4, 5, 6, 7. And I got practically, this is 1 comma, 1 comma, 43,800,000. Okay. Another one. Let's say 6.501 times 10 to power 9. Okay, 6 and then 501, 1, 2, 3. So another 6 zeros, 1, 2, 3, 4, 5, 6 zeros. Let's see. I had 5 here, right? And then going 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 2, 3, 1, 2, 3, 1, 2, 3. So 6,501,000,000, and that will be the number. Oh, how much I would love to put $sign in front of it. That would be nice. Okay, next. The same thing we do regarding small number. So let's assume I have 8.9 times 10 to power negative 8. So that is equal 8.9. I'm writing down here because I have to go to the left, right? Because I'm going to divide by 8. So my position was here, right? 8.9. So I'm going backwards. 1, 2, 3, 4, 5, 6, 7, 8. Okay, point is gonna be right here. So let me clean this. All right, let me do some shifting. All right, this is equal. So it will be 0 because point right here. So 0, 0, 0, 0, 0, 0, 0, and 8. So the number will be 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9. All right? And that will be our number. Okay. Next, let's do multiplication with scientific notations. So let's assume I have 3.8 times 10 to power 8. And I want to divide 0.2 times 10 to power 2. So what do I get? 10 to power 2 will be gone with 10 to power 8 will be here left 6, right? 8 minus 2, same base. So when we divide, we subtract the exponent. And 3.8 divided by 0.2, it's going to be, this is 1, this is going to be 9. Yes? So the answer will be 9 times 10 to power 6. Okay. Another one. Let me do another one. Would be interesting. So, let me see. 7.2 times 10 to power 5. 3.6 times 10 to power 9. So what's going to happen here? This is gone. Here we are getting 4 because 9 is greater than 5. So remainder going to stay with where 9 is. Okay. Now 7.2, 3.6. 3.6 is gone. 7.2 will be 2. And will be 2 over 10 to power 4. Since this format doesn't represent scientific notation, but it has to be 2 times. Therefore, I'm going to write down this way, 2 times 10 to power negative 4. Make sense? Okay. Now let me do multiplication. Multiplication, 6.5 times 10 to power, let's say 7. And multiplied by, I'm using this type of multiplication so you can see where is the scientific notation, times 0.3 times 10 to power 4. Okay, what do we do? Since all around multiplication, what I can do, let me see. I'm going to take 10 to power 7 and multiply by 10 to power 4 because we have same base, correct? And that is going to be 10 to 7 times 10 to 4. It's going to be 10 to 11, yes? And then I'm going to multiply 6 to power 5, multiply by 0.3. So let's see, 3 times 65. 3 times 5 is 15, 1 in mind. 3 times 6, 18, and 1, 19. So how many decimal notations we have? 1 here, 1 here, 2 decimals. So from here, 1, 2, it's going to be 1.95. And there we go, we multiplied. Okay, okay, let's do one more. 0.4 times let's say 10 to power negative 8. Okay, it's getting even smaller number. So times, okay, it's gonna be 7.2 times 10 to power 10. So what do we get? 10 to negative 8, 10 to positive 10. It's going to be 10 to power 2. And 0 0.4 times 7.2, it's going to be equal 72 times 0.4. So the 2 times 4 is 8. 7 times 4 is 28. Okay, 28. How many decimals total? 1 and 2. So if I come back, 1 and 2, I will get 2.88 times 10 to power 2. All right. And last version of scientific notation. Let's assume I have 85 million multiplied by 2 millions. So what I'm going to get total? So how I'm going to multiply? 85, I'm taking 85, multiplying by 2. It's going to be 2 times 5 is 10. And 1 in mind, 2 times 8 is 16, and 17, 170. And times, so I'm going to count total amount of zeros here. Okay? It's going to be 6 on this side. 6 on this side. It's going to be 10 to power 12, right? But here is something interesting. 170, it's not a scientific notation. So this type of notation cannot be called scientific notation. So I'm going to write down 1.7, right? Correct? And then when I put here, point here at 1, so I move by 1 more point, right? So once I move by 2 more points, then what's going to happen? This 12, if I add another 2, I'm getting 10 to power 14. And why I'm adding 2? Because of this additional 2 shifting I did. 170, I represent it as a 1.7. Okay? All right. Another one. It is going to be, next number, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 3, 3 times by 1 million. So it's going to be 67 times 1. It's going to be 67. But since 67 it's not a scientific notation, I'm writing 6.7, which means I have to keep in mind, I have to move by 1 more digits there. 67, I represent it as a 6.7. Let me do this way to make it easy. 67, step by step, times. So how many we have? 3, 6, 9, right? 12 and 15. 10 to power 15. And then I do 1 going back, and I get 6.7 times 10 to power 16. So let me clean this point here so it won't be confusing. Okay? That's exactly, it's gonna be our answer. I think I covered everything. Let's do the last case. Okay. Let's assume I have 0.1, 2, 3, 4, 5, 4 raised to power 4. What's going to happen? 4 to power 4 is 256, right? Times, how many I have here? 1, 2, 3, 4, 5. 5 digits, right? 5 times 4, this 4, it's going to be 10 to power 20. Negative 20 because I have to go backward, right? It's 0.0000, so I will get 256 if I put positive 20. So then my numbers will grow towards right, it will be even bigger, but I need smaller one. So it's going to be 10 to power negative 20. You understand what I did? Here 5 digits till 4, till this 4. 1, 2, 3, 4, 5. And 4 digits, and we have to power 4. So 5 times 4 is 20. And we put negative because number has to go to the left, towards smaller one. Now, since 256 is not a scientific notation, so I have to move by 2 more positions, 1 and 2. Okay? So my answer will be 2.56 times 10 to power negative 22. Okay? I think I covered everything. Okay, I can do one more like this. 0.1, 2, 3, 4, 5, 6, 2 to power 5. That will be equal. 2 to power 5 is 32, right? And then times, let's go count it here. 1, 2, 3, 4, 5, 6. 6 times 5 is 30, will be 10 to power 30. But because 32 is not a scientific notation, I'm putting 3.2, and then here is going to be 10 to power 32. 3.2. So, I mean 31, I'm sorry, where I moved only by 1 digit. 31. Okay? Well, thank you for watching, and I'll see you in next topic.